Welcome to Study Loop.
So in this problem, we are going to precipitate 99% of the magnesium ion. That means 1% of the magnesium ion will be left in the solution. So the concentration of the magnesium ion that will be left is 0.01. That is basically the 1%, and we'll have to multiply it by the concentration or the original concentration of magnesium ion, and we will have 0.001 molar magnesium ion remaining in the solution. Now if we let the required volume of sodium carbonate to add is x liter, the volume of sodium carbonate we need to add, if this is x liter, then the total volume after the addition of sodium carbonate will be, so we had 1 liter magnesium nitrate. That means 1 plus x liter will be the total volume. Now we have to find out um, how much carbonate ion we are adding. Since we are adding x liter sodium carbonate, that means um, carbonate ion added in number of moles will be the concentration of the sodium carbonate, which is 0.1 molar times x liter. So it will be 0.1x mole. So this is the amount of the CO3 2 minus we are adding. And now we have to find out the amount of magnesium ion that will not be precipitated or will be remain in the solution. So Mg2 plus remaining in the solution are the concentration of magnesium nitrate 0.1 mole per liter times the volume, which is 1 liter, times, since 1% of magnesium ion remaining, we'll have to by 0.01 or 1%. So the magnesium ion remaining is basically the product of this, and the value of this is 1 times 10 to the power minus 3. So this is the number of mole of magnesium ion remaining. That means magnesium ion precipitated is the original number of moles, 0.1 times 1 minus this remaining number of moles, and the result here is 0.099 mole. So this is the number of moles of magnesium ion precipitated. So again, that means that this is the number of mole of the carbonate ion used in the precipitation, as 1 mole carbonate ion will precipitate 1 mole magnesium. That means um, this is the number of moles of carbonate ion used for the precipitation. So that again means CO3 2 minus remaining as the from the total 0.1x minus um, the amount we used in the precipitation. So this is the number of mole of remaining carbonate ion. Now we have to set up um, the Ksp expression for magnesium carbonate. So the Ksp expression for magnesium carbonate is um, basically the product of these two ions, magnesium and CO3 2 minus. And here the magnesium ion concentration is 1 times 10 to the power minus 3 over the total volume, which we already calculated as 1 plus x, times the carbonate ion concentration, which is 0.1x minus 0.099 over 1 plus x liter. So these two are in actually number of moles, and these are liter. So if we just solve this equation, and we know the Ksp value for this magnesium carbonate is 6.82 times 10 to the power minus 6. So this equal to this expression. And then if we just solve this for x, the value of x will be found as 1.37 liter. So this is the volume of the sodium carbonate solution, which is required to precipitate 99% of the magnesium from 1 liter 1 molar magnesium nitrate solution.